What a sign, so you don't need to wait for yourself.
Okay, welcome you all to this community debate, the first community debate of our SEAMS community. Actually, it is a kind of follow-up of what we did in the past years, where we had special sessions on particular topics, but we tried to make it a bit more exciting. And I will tell you now what this means. So actually, the goal here of this session is to better understand how we look as a community at handling unanticipated changes. Are self-adaptive systems capable to do that or not? Should we look into that, or is it really completely not important? So we would like to discuss this issue and see where we end, because I think that there has been some discussion going on within the community, informal more, about this issue. So, and we will center the debate on a statement. And the statement is a kind of provocative thing. The statement is handling unanticipated changes is the ultimate challenge for self-adaptation. So once we solve the problem of how to do self-adaptation to deal with unanticipated changes, our work is done. That's a statement for this debate. You can like it or you cannot like it. That is exactly what we want to discuss. Let me tell you a bit how we will work here this afternoon. So I'm now doing this part, the introduction, tell you what it is all about and how we will do it. So in the next stage, you will soon see it, you can make a vote for this statement that I just showed you. And once that is done, we will then give the floor to 8 people from our community that will explain their position with respect to the statement. And there are actually 2 groups. One group is more tending to be in favor of the statement, and the other group is tending to be against the statement. So we will see the contrasting positions here, and hopefully that will be a good source of discussion. Actually, once these guys have done with their position statement, then the debate actually starts. So then everybody can participate, and we would like to ask you to put in the chat your questions, preferably here in the Zoom chat that I can see them. And then I will try to moderate as good as I can all things. After the debate, you can again make your vote and take a position and see whether you still are okay with what you said before or not. And then at the end, we will look at a last issue that are challenges, and we will then make a conclusion for the debate. So let us start now with the first round of voting, and Ilias will organize the voting rounds.
Yes, let me share my screen and show you the first question we have for you. So we're using Mentimeter. So in case you haven't used it before, it's very simple. You have to go to menti.com and use this code that is shown here, 9501-9900, and answer the question that you see here. I won't show the results. I'll just hide them for now, so that I just wanted to make sure that this works. So we can see here how many people, and I'll give 2 minutes, right, Danny, to close the voting. So please use the 2 minutes to think about whether you agree with the statement and pick an answer.
40 more votes to go, I see. It's anonymous. You don't have to be afraid. We will not know that you were the one who completely disagreed.
Unless everyone disagrees completely, then.
Can say you're the only one to agree.
No, don't bias people. It's a very serious process.
Ilias, what will you do after we go back to in-person meeting and none of this virtual stuff matters anymore?
Oh, I would be happy. Yeah.
I'm
All right.
joking, of course, but
Let me show the results. I think it's H. Yes. Aha.
Okay, this looks like not really a good ground for having a heavy discussion here today, because there seems to be a lot of agreement on the statement. Yeah, so there's work for those people that that disagree with the statement to see whether they can make a point and change the minds of people here. Okay, Ilias, can you give me the right again to share my screen?
Yes, try again now then.
Yeah. So these are the people that will make arguments here to motivate us, and that are arguments against the statement. We will start with Gregor, then David, then Yehaya, and at the end, Owen, who will speak. So I will give now, Gregor, you the right to get access to the screen. So now you have full control over my computer here, if it works all well.
Yeah. So hi, Danny, but I think you have the slides, so?
Yeah, but you should now with your mouse be able to manipulate the screen and move the slides. You have the, you can do it at the bottom, yeah.
Yeah, but I was expecting that you have the slides and I only move the slides. But
Yes, you should move the slides. Did
So,
you got?
I still see my,
Ah, sorry, yeah. Here is your first slide, but you should now
Thank
be
you.
able to manipulate the slides. Move
Okay.
them.
let's try.
Yeah.
Okay, anyway, let me start because I only have 10 minutes. First, let me thank you that I'm invited here to give my opinion about this. And as a good scientist, I always say no in the beginning. Because when you're a good scientist, you have to say no. You have to say, let's think about this. And then I was thinking about this, and I still am saying no. This is not the ultimate challenge. So my statement here is that the ultimate challenge is that we try to prevent unanticipated changes, so that we try to predict the future. And this is my statement. So I think this is the ultimate challenge: to predict the future, to prevent unanticipated changes. And I cannot move. Danny, can you show the next
Okay,
slide?
I will then go to the next slide for you.
Yeah, thank you. So what you see here is some examples where we already experience this in our daily life, that we predict the future. So if you go by car and we go through the forest, and then there might be some wild animals, a deer and so on. So we can see that there is, maybe you can even show the next slide, the next part of the slide, Danny, thank you. So then there are signs which show me there is, be aware, wildlife is crossing. So due to experience in this street, in this part of the region, the forest, there quite often are animals, wild animals or deers. So the future is predicted. So this is experience, based on experience. The same is for weather forecast, the thunderstorm and so on. we have the weather forecast, and the weather forecast helps to prevent that there is suddenly a thunderstorm and you are not was not waiting for this, so you are warned beforehand. So this is the idea of weather forecast, to warn you before bad weather. And the same is now what we see with predictive maintenance. For instance, here's a broken tire. The idea of predictive maintenance is to use the experience from the past, to use the experience from many similar events to predict what will happen in the near future. And so this is not at all anticipated that there is a tire will break or that the thunderstorm or the animal will appear. It is predicted. But the challenge is to do the right prediction. And so my last slide, Danny, shows how I propose to solve this issue. And so to be a good scientist, I not only say no, but also propose a new and novel solution for this. So on the left-hand side, on the top, you see the traditional MAPE-K cycle. And my statement is that in the past, we didn't thought enough about what means analyze, plan, and how to use the knowledge, the K of the MAPE-K cycle. If we try to control or to predict or to handle socio-technical systems, cyber-physical social systems. And so I say we have much more to store information about the past. And this is the K extended by the persistent data with information about the past, and also with information about the current situation. And this is the novel topic of having a digital twin of the environment, of the context, of the system, and to use this digital twin to predict the future. So based on this digital twin, all the information, the data is there, we need better algorithms to analyze, better algorithms to plan, and by this, we can predict the future, and we can change the system before something happens, what you might call unanticipated. I call this is anticipated, because I know this because of my algorithms in analyze and plan based on the digital twin. The strange thing here is as a small red arrows, which means especially that I'm able to change the context. In the enactment part, I have the ability to change the context. And also on the left-hand side, I have the ability to monitor the context. And this is now what I have in the bottom part here. The question is whether we really wanted what I propose here. Would we really like to predict the future? Because this would mean that we have to control and to monitor and to look at the whole life of all the context and so on. And in this way, to be predictable, what will happen tomorrow, next minute, and so on. So this is a trade-off here we have to discuss. So I say this is the ultimate challenge to predict the future, but there's also maybe the ultimate danger that then we start to control our society. And in this sense, we have to be aware that we have not only a technical issue here, but also an ethical, legal, and privacy issue. This is my statement. So no, with your statement, but the challenge is to predict the future, but be careful with doing this because it's dangerous. Thank you for listening.
Thank you very much, Gregor. Then I give now the word to David. David, if you can control the slides, otherwise let me know. David, can you hear me? You might be muted because I cannot hear you.
There we go. Okay, can you hear me now?
Yes.
Okay, great. Now, do you have slides?
Yes, you can control them normally with your mouse on the bottom left, the arrows.
Sorry, okay. I don't see a panel here, but hopefully I can.
If it doesn't work, I can move the slides for you. Eh?
Okay, all right. All right, so yes. So you've put me in a position of disagreeing with the statement, although I have some reluctance in being put in that category. It does remind me a little bit of the kind of thing an adversarial lawyer might say to a witness who says, "Is it true, sir, that you've stopped beating your wife?" Well, how do you answer that, true or false? Because in order to even answer that, you're admitting somehow to having been beating your wife in the past. So, I have some problem with the very terms that are being used here to frame the question, but I think that can lead to an interesting discussion. In particular, the terms ultimate and unanticipated changes, I think, need to be looked at a little more carefully. So what I want to do is look at, in particular, at this notion of what do we mean by unanticipated changes, and argue that there's some nuance to that space that we can leverage from an engineering point of view. And so I apologize for the mind-twisting title. The unknown unknowns are not totally unknown, but I'll try to explain what I mean by that. Okay, can you advance the slide? So I think often we find ourselves in a false dichotomy where we think there are anticipated changes, and these are the ones that we engineer our control and our adaptation to handle, and then there are the unanticipated ones, which are outside the scope. In some sense, they don't satisfy the preconditions of our control envelope. And for those, we say, well, all bets are off. We can't guarantee anything. But I think that's a mistaken way to approach such systems. And I'd like to argue that there's a third category. And that the third category are things that we are not controlling for at the moment, but we can anticipate in the future likely to be things that we may need to control for. And so I'm terming these things the known unknown unknowns. They're things that we don't know at the moment, that we're not going to build our system to adapt to, but we have some idea that these will become important later. Now, as we think about those, this may be very domain dependent. You know, in certain domains, we may know there are certain kinds of evolutions of the classes of environments we're going to be in, the requirements or the kinds of system states. But in many cases, within a particular domain, we can actually quantify some of these things and plan for these for the future. Now, one might say, well, if you sort of know about these, why not build them into your system anyway? Why not just make them part of the set of anticipated changes? And I think the answer is control systems in general can be optimized for efficiency if they work within more narrow domains. And so building control that has to deal with a lot of things that aren't going to happen is often a waste of energy and time and efficiency. So we want to keep our systems tailored to the kinds of unanticipated or the kinds of changes that it needs to cope with, but we also need to be able to evolve those. So I think the real question is, how can we build our systems so that we can anticipate, in some sense, the things that are unanticipated? So I'd like to, next slide, suggest a theme that's appeared in before, but in a variety of contexts, but I think is worth bringing up to the frontier as we talk about this situation. So could you do one click? So if we think of our normal system as what we might call first order adaptation. We're building some kind of control that senses the system and then changes it to adapt as needed to maintain certain kinds of properties we care about. So if we think about encapsulating that, next click, we can imagine a second order adaptation, which is in some sense monitoring the adaptive capabilities of our basic system, and then in turn adapting that, perhaps extending its ability to deal with new kinds of environments or contexts. So this idea of a second order adaptation allows us to build in at a higher order some notion of the kinds of things that we'll be looking for that will maybe need to be changed in the first order adaptive system. The question then becomes, what are the engineering techniques that we can use to make this possible? Well, first of all, of course, we need to be able to have a control interface for the second order adaptation. We need to be able to sense and model the system that is adapting and change it. And there are a variety of techniques I think we can use that have been used that are in some ways commonplace, but we can think about them more systematically about building systems that will allow this, if you will, meta adaptation. One is to build in a certain amount of over-engineering into the base system, so that as you change its control from the meta level, you have the resources within it to do that. This is very good, are very common actually in systems like NASA systems, spaceflight systems, where they'll build in a certain amount of extra capacity, not expecting to use it, but allowing it if they have to change things. The second key issue is how do we build the kind of interface to the first order system that lets us know what it's doing, measure its effects, and determine when it's not actually adapting appropriately. We can also build a system where we assume less. A good example of that would be in the security world, where we may have detailed models of vulnerabilities and threat actors, but in the future, we don't know exactly what our vulnerabilities will be and who those attackers might be. So if we build our system sort of assuming that we know less, even when we do know more, we often can build in some flexibility. And finally, when we think about adapting the first order system, we can build it with more reusability in mind. So we've done some recent work over the last year or two on how do you create components of a planner that can be reused in new contexts through genetic algorithms, essentially sort of building the building blocks that a higher level form of control can use to create new plans, new control as needed, and much more efficiently than having to do it from scratch. So I think these are just a small set of things, but once we view this as the engineering problem, how do we manage to keep our first order adaptation current? We can use the same principles that we've been using for it, but simply at a higher level.
Thank you very much, David.
Mm-hmm.
So then now, Yehaya, I give you the word. You should normally also be able to manipulate the slides. If you need me to support you, let me know.
Yep, can you hear me now?
Yes.
Okay, hello everyone. So this is a culmination of a number of discussions I've had with my colleague Abdeslam Al-Habash, and we have a provocative answer to the provocative question that has been posed. But let me first thank the organizers for having the community debate session. I think it's a brilliant idea. So our position is that we disagree with the statement, and we're going to be putting forward an alternative ultimate challenge, which I'll talk about in a second. So as we see the literature from our side, we observe that there's a lot of attention, especially recently, on the means of adaptation, how we adapt, whether it's using automata or more recently using machine learning and deep learning methods. And this is the ultimate goal of a lot of these automated self-adaptation systems, is to eventually eliminate the involvement of human users. And I think Rogerio gave a brilliant talk about that last year. But we are also observing this with a mixture of excitement. This is really exciting developments in the area of self-adaptations, but also there's a little bit of apprehension because this human input post-deployment of a system is actually quite critical, both for comprehending how the system is adapting, but also to intervene and provide critical steering when it is needed. And this is not something new. This has been documented in many areas where automation has played an important part, and this is known as the automation paradox. With more automation, human intervention becomes more critical. So instead, we see that the ultimate challenge for the community at this particular point in time is to provide means of controlling automated self-adaptation by involving the human user. And I think there has been an excellent demonstration of that yesterday in Jeff's keynote, where he showed us a very brilliant demo of how a self-adaptive system can interact with a human so that the human can provide critical steering with the help of the system. So there's a number of things that we believe can be done within the community. And to summarize them, it's basically providing interaction surfaces between the knowledge that is held by the human and the knowledge that is acquired by the system, by the machine. Oh, I'm missing a slide. Ah, there we go.
No, sorry. This is the right slide.
Yes, thank you. So these can be summarized into two main areas. The first, you can split them into the human to machine interface. So before a system is deployed, and the second one would be how to evolve a system post deployment, which is the machine is talking back to the human to provide some more input. So in the first category, we believe that there's a lot of work to be done to enable developers to change the inner structure of an application. So for instance, there's a lot of machine learning libraries that allow you to make predictions about certain metrics, but there aren't any libraries to allow you to change the inner structure of an application. And this would be a very useful tool for system architects. For researchers, there's more need to share their data sets, share their reproducible practices, and how they calibrate their models in order for us to have efforts that are reproducible and results that are reproducible in the community. And also there's need for involving domain experts who are not software engineers as equal system co-architects. So for instance, if I'm building a self-adaptive system for an industrial use case, for instance, then the domain expert needs to have tools where he and she can also provide input from their perspective. And currently we don't have any such tools. In terms of evolving a self-adaptive system, there's still some things that we need to be working more on. So human input is required, for instance, for things like early detection. Having been working on machine learning, application of machine learning methods for the last 4 or 5 years now, I can still see that humans are much faster at detecting issues such as overfitting, and this is still the case. Human input is also needed for detecting when data quality is not very reliable. And there are also things that are unmeasurable. So there are some aspects that we don't have the capability to reason about using software alone. So things such as ethics, equality, inclusivity, all of these things, we need human input. It's very critical in order to make sure that these aspects are addressed. Also, there are significant decisions, decisive calls that need to be made, that we cannot rely on a self-adaptive system, no matter how sophisticated it is. So for instance, when to declare that a patient is dead, or when to make a decision in a safety critical system. And finally, to enable humans to provide input for meta-reflection. So to check whether on a periodic basis or otherwise, where the overall adaptation goals are still valid, are still well represented, and ideally they're modifiable, so they can be adapted when and if needed. So that's our position. Thank you very much, and I look forward to more discussions.
Thank you. Normally we have Owen now, but I don't see him. Owen, are you there?
I'm here.
Okay, I don't know how I can give you access because
It's okay. I don't think I need
just tell me and I will move your slides, okay?
Yeah, thank you. Hi, everyone. I haven't been in really attending SEAMS for a while, over a decade, in fact. I mean, we don't count last year, right? I'm currently at Aurora Innovation, working on self-driving car, but I've been asked to make it clear that this work is separate from my role at Aurora. So with this provocative question, my stance is that I'm actually against it. My position is that change alone is actually sufficiently challenging for self-adaptive systems. You can advance to the next slide. So what I guess unlike David, I wasn't quite able to pinpoint why I was uncomfortable with the question at first. Hadn't realized that I was forced to, admit certain things. The joking aside, though, what I thought I would do at the time was basically look at, go through a journey of existing systems, at least my imaginations of systems of sort of the future. And I kind of tackled 4 fairly different domains, thinking about, hey, what does a engineer need to think about to design a system that's self-adaptive for this particular application? And by going through that journey, I wanted to see if then we can understand what are the anticipated changes versus what's called the unanticipated changes. And in that journey, it occurred to me that, hey, if you can actually start to think through some of the quote unquote unanticipated changes, something that David actually alluded to already in his presentation, is it still unknown at that point, right? That's kind of an interesting point, like, and this kind of harkens to the chat about requirement engineering. If you're actually thinking about your problem space thoroughly, what are things that are unanticipated and unknown unknowns? Okay, so as I kind of think through a thermostat, an eco-intelligent thermostat. So I apologize, I will have to refer you to looking at my paper on the specifics of each of these systems. I didn't actually seek to summarize it here. But with the thermostat, that seems to be a fairly easy system. But what if you have to have the thermostat start to understand the composition of the windows of your house, or understand, the energy kind of sources that you're drawing power from? How do you then make that system eco-intelligent? And what are anticipated changes, right? Because you can probably imagine all the analytical models out there for predicting seasonal changes of temperature and climate and, energy consumptions, etc. But what if suddenly we had fusion energy? Is that an unanticipated change that system needs to be designed for? So that's one of them. Looking at a different problem, a vacuum cleaner, basically, one of your robots, right? It's a typical robot. So what are the unanticipated changes? Well, what if you need to design the robot to cater to all kinds of different sizes, and you're trying to maximize the overall, again, energy consumption and the minimized number of trips that the robot has to go back and recharge, right? How do you design that? And where are the challenges there? For asteroid miner in deep space, wow, the unanticipated changes there could be fairly a wide variety of them. But then again, you can actually think through a number of the different scenarios. Like, what if the asteroid we thought had this particular hardness actually didn't? Well, we can seek another asteroid, perhaps in time, and then pack enough energy to make that additional trip, right? So there are different things you can consider. And then on to sort of the self-driving city bus. This one I went into a bit more detail, perhaps because of my work experience so far and my interest. So when you think through some of the changes, some of the things that you have to think about for a self-driving city bus, the lines start to blur in my mind, what's anticipated versus unanticipated. And that's actually kind of interesting. I'll highlight a few examples that I wrote down in the paper. One of them is a child emerging suddenly from between parked cars. You might say that's anticipated, right? We should anticipate that, and I would totally agree. What about a sinkhole in the road? We've had one in Pittsburgh where a bus completely sank in, the rear of it sank into the to the ground. Is that something that we should have anticipated? Or, that's again an interesting argument, right? Then we kind of forward to the set of unanticipated changes. Ridership surges during football game or a convention. Is that anticipated or unanticipated? That's arguable, right? You could say, well, if we knew all of the events that could occur within the city in a month's time, we should be able to anticipate ridership surges. What about collapsed bridge? What about a meteor suddenly impacting and eliminating all the routes to the endpoint, right? So you start to get really crazy about the possibility. Okay, so I've kind of gone on a bit. I think I've made the point. My point here, we can advance to the next slide actually, is that my key assertion is the following. If we can actually solve for the anticipated changes, it's likely actually going to get us simultaneously closer to tackling the handling of unanticipated changes. So that actually leaves a number of key challenges to think about. But I will sort of have a parting muse here. Is this really the right debate question? Okay, I'll end with that.
Thank you, Owen. Okay, now we get the speakers for those that are in favor for the statement. And I will start with Martina. Then Thomas will follow, Ivana, and finally Jeff will give his position. So Martina, you should be able to move the slides now.
Yes, I am. All right. So hello, everyone. And as Danny said, I'm glad I'm starting the in favor positions because I'm actually not in favor. I'm precisely in between. So what I think is handling unexpected change is hard, but it's not the hardest thing we have to do. So let's think about a person. And a person starts like on a regular day, they start from home and they go to the bank and pick up some cash. And then they go to the grocery store and buy some groceries. And maybe they stop by and buy some bread. And now their kid or their partner call them and say, well, could you please buy a book for me? And in a cash-based society, let's say we can only pay with cash. And if we are called between 2 and 3, we may not have enough cash to also stop at the bookstore. But if we were anticipating the fact that we might receive a call and ask for more things, more errands to run, then we could have gotten more money from the bank. And maybe we can decide to pay with, so maybe at the bookstore we can only pay cash, but in the grocery store we can pay with a card. And then this would not be a problem again. We can use the cash we got. So there's, what I'm trying to say there is that there is a lot of room for replanning. And in reality, this replanning is very often not so complicated as long as we have constrained the type and the amount of uncertainty that we are getting in these systems. So let's say, for example, I can only be called to do errands that amount to some additional money. Then if in advance I had taken that into account, I could have gotten that money from the bank, and I know I should be safe in every possible circumstances. And the same can be done with software. So I could have more requests on a web server, but only up to some more that I can over provision, which is done in practice. Now, the question is, can we put boundaries on the type and amount of uncertainty that we are going to get? So can we say the equivalent of we are only going to be asked to run errands for $100? And the second point here is that, so first, the first big challenge is characterize the uncertainty, characterize what is unexpected or what could happen unexpectedly. Now, if we look at autonomous driving, for example, characterizing these unexpected changes that could happen will be different depending on whether we are on driving on a highway or driving in a city. And then we have a different set of uncertainty that we have to take into account. And maybe we will discover that certain things are possible in a driving scenario and are not possible in another driving scenario, because in the second one, the uncertainty could be too much. The second, and in my opinion, the real challenge for self-adaptive software is certification. So for me, the challenge is how to certify that the adaptation layer is not screwing up what the software is doing, that we are always doing the right thing, despite the fact that we have this adaptation layer. Because verification for software has done huge steps, and we are actually able to verify entire operating systems these days. But still, when the software changes its behavior, can we still verify anything? Can we still certify the software? And for me, that is the ultimate challenge of self-adaptive software.
Thank you very much, Martina. Thomas, I give you the word now. You should be able to control normally.
Thank you. Thank you. Good. Welcome. I'm actually very happy to follow exactly after Martina, because my position is also like spot on in between. And as we had quite few people who were like more in favor, more like tending to agree, I also try to emphasize a little bit the points why I think it is not so clear, why it is somewhere more in between. So my position kind of by definition is yes, handling unanticipated data changes is a challenge, but maybe I would be asking whether it's a long-term challenge and whether the challenge that we have right now is not something else. And it seems to me that maybe the challenge that we have at the moment might be a bit different than really this penultimate challenge of handling unanticipated changes. And maybe if we kind of solve the challenge that we have now, we will have better means to solve this bigger challenge of the unanticipated changes. And basically what I would like to argue a little bit is that maybe we are getting a bit too technical in our questions. And maybe we are losing a bit of the broader context of like the society or to be kind of more down to the earth of, for instance, the funding schemes. Like now I will be like talking on behalf of the EU-based research. And I have been checking lately the new program, I mean, the Horizon Europe, which is like the new funding scheme, the continuation sort of H2020, which is gonna basically define for what we are gonna get money from EU in the next couple of years at least. And funnily enough, out of those 200 different calls for the next 2 years, and out of those, I don't know, 30 or so calls that are somehow devoted to IT, there is pretty much nothing about self-adaptation. There is, on the other hand, a lot, and really a lot, about machine learning, for instance, AI. I mean, those are the keywords which are somehow important, or I'm not saying they are important, but they are somehow considered important, at least by the people giving out money. So my question here is whether by focusing on technical challenges, we are not forgetting a little bit to also guard our position in the overall research landscape and kind of in the overall research context. And what I would like to propose here is that we should kind of try to focus on, like with this unanticipated changes, how we could support the other things that are somehow considered important. For instance, like we use quite a lot of machine learning. We could see it in like a lot of presentations that we had so far and that are probably going to come. But then the question is, from all what we know, can we somehow support the machine learning? Can we like reverse the roles? Can we sort of make a like equal positioned marriage? So it's not like we are just taking machine learning and AI, but we can also somehow support it. So can we somehow become crucial for machine learning? We have heard quite an example already, where the point was in machine learning, there is a problem of overfitting, and it seems that overfitting is better handled by people. I would say this is how failure. And I've been doing machine learning lately myself quite a lot. And with all the knowledge that I have on self-adaptation, I ended up manually tuning things, though I created some framework on which does the automated experiments, etc., etc. And still, I mean, with all the body of knowledge and the tools that we have, etc., I couldn't really support myself in like doing the machine learning really automated, to really like let it run on Amazon for next 24 hours and get a result which would be somehow meaningful. I had to like go to the system, check it like every couple of hours, make adjustments, make sure that I'm not just burning money for tasks which shouldn't have been run anymore because they make no sense after the data that have been gathered so far, etc., etc. In my view, this is machine learning. And also we had quite some discussion yesterday when we were like talking about, yeah, I mean, how we can support machine learning. And for instance, Colin suggested that we could like stay in the situation and like explore it. And also now, so far, we have heard quite a few good ideas about like controlling the context, about making things more predictable. So somehow controlling things so that they happen in the context in which they should be. And I would say maybe this is something that here I kind of dared to term self-adaptation 2.0, which is a bit like saying, we are not just reacting to the context, we are actively creating the situations. We are like changing or controlling the context so that our like unanticipated things may be less unanticipated, or that we can, for instance, learn more from the situation so that we can, for instance, support the learning if we are focusing on this. And oh my, this is too much. And I believe that if we can somehow support this learning, and if we can, like, for instance, become useful for the learning, controlling the context really make difference in this, we could become very relevant in the research landscape as it is now. And in the end, we might actually achieve, by this sort of equal marriage, we might actually achieve this penultimate goal of handling the unanticipated changes. So I believe, yes, it is relevant, but maybe the problem that we have now may be a little bit different. And maybe we have to redefine a little bit what we mean by self-adaptation. And maybe we have to make a bigger step to really, I mean, step out of the box, what we mean by self-adaptation. So that's it. Thanks.
Thank you very much. Thank you very much, Thomas. Ivana, the floor is yours now.
Thank you very much. I don't think I got the, oh, let me see if I...
Yeah, you can now control it.
Control it? I can, perfect. So Nicholas and I are firmly in the pro camp, but as you'll see through our presentation, we actually agree with some of the statements from the against camp, but we think that they actually kind of fit better in the pro position. But before I start, and Bashar will like this, we first define what we mean by each of these words, because I knew we were going to disagree of what do we mean by handling, what we mean by anticipated, and so on. So for us, it's not about just handling, because handling can mean preventing by predicting, as we see in the first part. It can mean fail safe. We firmly mean adapting to. Also, we redefine unanticipated. So what we see as unanticipated is unanticipated to system, but it's still something we know exists in the world. So it's known to users or engineers. We're talking here about completely unknown situations. So what we're saying is the ultimate challenge is adapting to unknown situations. And how do we propose to do that? We've heard that come up a lot of times today in various combinations through use of learning-based adaptation. Now, how do we do that? As you saw on the previous slide, it's going to take a lot of magic to achieve that, but worth starting. First part is, how do we represent the environment? How do we represent the unknown? We can't adapt to it before we can make sense of it, observe it, decide which part of what we're observing is relevant. How do we represent it? What importance do we give it? And similarly, some of the things we used before to take into account, they might not be relevant anymore. How do we remove them from our representations and subsequent learning processes? Second one is, now that we have information about what the new situation is, we have to look at what we know and what behaviors do we have in order to see if this in any way relates to the world as we know it. We need to assess similarity to previously seen situations and retrieve bits and pieces of useful behaviors to mix them and modify them to adapt to new situation. And in order for this to happen, we need to have underlying robust continual learning mechanisms. So we see a lot of papers popping up in the community that are learning based, but we're learning one thing or a certain range of things. We need a lifelong learning process where we gather all the previous knowledge acquired by learning these individual tasks to be captured, memorized, linked, and so on, so that we can generalize and reuse. And then thirdly, it's important to know when to give up. Can the new situation that we've encountered and never seen before be so different from anything that we've seen before that we just can't meet our goal anymore? What do we do then? Instead of plain giving up, we propose that systems should come up with alternative proposals for the goals, kind of saying, okay, this is the situation, this is what I know how to do. Propose alternatives given the skill set that it has. Jeff talked a bit about this in the keynote yesterday on system proposing modifications to utility function when the system isn't meeting its goals, but going to the even more extreme examples of this where we might have previously unseen variables added to utility function or brand new utility functions. And finally, if we end up having systems that do all this, do we want them running wild in the world? And sorry, I was meant to be going back to the previous slide here. And we argue, and this is the part where we agree with one of the con positions. We argue that human is even more important part of self-adaptive process at this stage, especially if we are proposing modifying the goals, modifying utility functions, and so on. So we need humans to either help with some additional domain knowledge or to ensure that goals of the system are still compatible with human goals. Because again, going back to Jeff's keynote, sometimes humans aren't exactly sure what they need when they build a system, so that needs adapting. So our final position summarizes as, yes, handling the unanticipated change is the ultimate challenge of self-adaptive systems, but with the goal to continue meeting not their own goals, but goals of the users and operators in the presence of these new environment conditions. Thank you.
Thank you, Ivana. Thank you very much. So then, Jeff, now you're the last speaker of this part. Thank you.
Okay. Thank you. As I told Danny some months ago when we were talking about my participation in this debate, I found myself in a state of great uncertainty about what position I take on the topic. And in fact, the title of my talk has undergone a last minute unanticipated change. Let me see if I can actually control this here. There we go. So this is actually the title of my talk now. It's only a 4% perturbation, but it has some significant consequences. So let me start with some definitions that have been culled from the extensive literature on adaptive systems. So we have a definition of software agents from Nick Jennings. We have the definition of autonomic computing systems that Dave Chest and I put forward in our Vision of Autonomic Computing paper. And from Danny's website, we have a nice definition of self-adaptation. And if you look at these definitions from the right level of abstraction, all of them have to do with some sort of adaptive system that is taking actions in an effort to manage themselves in accordance with goals that have been specified, maybe at design time, maybe at runtime. So another way to look at this or represent it pictorially is here. So here's a self-adaptive system situated in some environment, and it is striving to take actions, maybe operational, maybe adaptive. I think this maps to David Garland's first and second order adaptation. They're trying to do this in service of these goals. And perhaps in order to do this, it might well try to have a model of itself and of the world. The model may be a little off, the color might be wrong, the spelling might be slightly wrong, but hopefully it's good enough to do some sort of adaptation. And so we as a community tend to jump in and say, oh, I want to figure out what should be the algorithms that drive those actions. Let me show how we can do clever modeling and simulation and optimization. We jump right into that. And I think all that, and show how we can do this in the face of changes, be they anticipated or unanticipated. And I think this is good. I'm glad that so much energy and effort is going into this, because I do think it is a difficult and centrally important challenge. But I think I faked Danny out a little bit with all of my equivocality, and I find myself now in the camp of disagreeing with the premise, because I think there's another set of challenges that are more ultimate, and those have to do with really the topic of my talk from yesterday. It's what is the goal? So let's talk about goals a little bit more, because I feel that we've not paid nearly enough attention to this issue of goal specification. So let's first say a little bit about what form do goals take. And of course, the classic approach to specifying goals that's been around for thousands of years is the stone tablet. This evidently works well. It's been very influential in the world and has lasted thousands of years. We may have other more modern ways of indicating what are certain constraints, but same idea. Now, I'm going to mention briefly, some people think of if-then rules as a form of goal, and I put it here so that I could explicitly cross it out and say, I don't believe that rules are the right way to specify goals. So those are gone, but we can indicate preferred states in a number of ways. We can use utility functions and the like. What about the question of who sets those goals? Well, in Nick Jennings' definition of agents, he talked about design goals. So yes, it could be the designer. Danny, in his definition of self-adaptive systems, talked about goals in such a way that it was clear that they were set at runtime. It could also be a service provider. It could be the government, or as we saw in the first example, it could be God. Any of these and some combination thereof could be setting the goals. And finally, there's the important question of how and when can they be elicited. And one thing that makes this especially challenging is, as I said in my keynote yesterday,
human irrationality. People don't know how to express what they want. And I'll repeat again this quote from Greg Ganger that I like very much. Humans are not good at precisely specifying what they want, but they're very good at complaining when they're not satisfied. It's very true. And not only do people not know how to express what they want, often they don't even know what they want. And we saw that certainly there's the work of Tversky and Kahneman, Nobel Prize-winning work on this. There's the example I presented yesterday from Dan Ariely's book that really illustrate this quite compellingly. And so where does that leave us? I want to say, since I'm since I'm actually coming out as disagreeing with the debate topic, so what do I think are these ultimate challenges? Let me try to condense from my ruminations of the last few minutes what are a set of challenges. So one set of challenges has to do with representing and eliciting goals in the face of human rationality. So combating the natural human cognitive biases, being able to support complaint-based tuning. And what this really means is we have to accept that changes in the goals are not going to be some occasional, oh my God moment, but it's going to happen continually all the time. And systems have to just accept as a matter of course that goals are going to change. And they shouldn't just take it that as the human changing their mind occasionally. I think that machines or systems, adaptive systems, should take an active role in helping the humans with the formulation of the goals by, for example, helping them understand the potential consequences of certain intended changes. And you can almost imagine a sort of negotiative process. You know, human, if you do this, I want you to just realize that these are the likely consequences. You okay with that? I think the issue of mediating preferences across multiple stakeholders and authorities is very important. Who's really in charge? Often there are multiple stakeholders, and how do you resolve these conflicting preferences is something that we really have to broach as a community. We have to factor in social norms. And in fact, social norms may be part of what would motivate an adaptive system to come back to a human and saying, you know, this goal you put in looks like it might conflict with this norm. Are you sure you want to go ahead with it? And legal requirements, both how do you factor that in, and how do you read a legal document and somehow translate that into machine form of preference representation. And finally, you know, how do we take high-level system goals that have been specified and translate them into individual component goals? I gave one example of how that could work with utility functions yesterday. I'm sure that there could be a lot more work in this space. So to summarize, I feel that coping with unanticipated changes is very important, but it's not the ultimate challenge. It's a prerequisite for this, which I think is the ultimate challenge. So thanks.
Thank you, Jeff. Thank you very much. So now the floor is open for the discussion. Sorry. Can you imagine that we got here? Can you imagine what it is, a task for a chair of a debate, if you see that there are over 100 questions here? So let me see where we can start here. Eh? Give me a minute or a second or 20.
I think Jeff also raised his hand. Radu as well.
I mean, there is a lot of conversation. There is a lot of conversation on the chat system, which can abstract from actually.
Yeah, I think then you go with people answering questions directly without the chat.
Mm-hmm. Okay.
I agree with that position.
Okay, good. That's good. Then Who wants to start here? Rogerio?
I was hoping not to be the first one, really. Okay. So, so usually I think people who listen to me, usually I try to classify, concerning dependability and security into three groups: the optimists, the realists, and the pessimists, right? And I was trying to classify this conversation into something, right? So the only one I could find was the skeptics, the believers, and well, it depends, okay? So this is, because when I start looking at your sentence, sorry, Danny, only now I start really thinking in your sentence, very nice sentence, all right? There is a big assumption there, all right? And the big assumption is that actually you are able to detect what are the changes, right? So if a system is not able to detect what is a change, how are you going to classify the change as anticipated or unanticipated, right? And the problem starts there, right? So, and there's an issue that will carry on, all right, because is the notion of observing, the system being able to observe its world, right? And if the system is not able to observe this world, right, even reasoning about indirectly what the consequences of the events, the change has not happened, all right? So going back to Hitchcock, all right, there is no such a thing as a perfect crime. That's my statement.
Maybe before I give the word to someone else, maybe Ivana, do you want to respond to that? Because I think in your talk, you were exactly hinting towards how you could do that.
Yeah, that is part of the thing. If I'm a system that I don't even have sensors to observe something has changed, all I can observe is happening, that I'm not meeting my goals anymore. I can't observe why, but I know I can observe myself. I know that I'm not doing as well as I am. So that's the only way I can observe that something unobservable with my interaction with the outside is happening by looking at the inside. And that's where we need humans, because if I as a system can't see it, maybe humans can.
Yeah, Danny, if I can chip in a little bit, because I think it goes a little bit further than that. It's not the fact that you can just sense the whole environment, but you also need to make sense of what you are seeing. So whether your sensor is giving you a value, you need to understand what that value means for the current context of whatever is happening around you. And that is important. So you need to be able to capture that intrinsic knowledge somehow. And that's why we're saying that at some point you need to ask around, because that's the way we actually cope with all the new situations that we have.
Okay, fair enough. Radu, I see your hand also raised.
Thank you, Danny. So my notes say that there is good news and there is bad news. So to me, the good news is that we as a community set out to solve an unsolvable problem, which is fantastic news because we want to have plenty of work to do, and that there are new, younger, early career researchers joining the community. So there will be plenty of work for them to do. I think my position is perhaps very similar to Jeff's in a way, because I have the view that indeed unanticipated changes are a huge challenge. But I have to say that for us as a technical community, that they are very much the comfortable, the secure and easy challenge to tackle. And if we continue to work, we'll carry on pushing the boundaries and making advances. But I feel that there are bigger challenges of a different nature. The challenge of identifying trade-offs and compromise among goals of different stakeholders. So that those don't have necessarily something to do with unanticipated change. The challenge of starting with the right assumptions when we develop these systems, and we defining the operational design domain, the challenges of trust, assurance, certification, and a whole variety of socio-technical challenges, some of which Jeff mentioned, such as legal challenges, that they need to comply with social norms, perhaps cultural norms and ethics as well. And to tackle some of these requires more than our technical knowledge. It requires us to work alongside other disciplines. And I would say that that's, to a great extent, a bigger challenge that we need to work on, potentially, I don't know, by organizing special sessions, it seems, to invite people from other disciplines to such debates, perhaps through organizing Dagstuhl seminars, Shonan meetings, that would not only have us as participants, but also people from sociology and psychology and law and so on. So that's, I think, what I wanted to add. And these are in a way less good news. We won't be able to handle these challenges on our own.
Okay, thank you, Rado. Now, let me first, I will give immediately the word to the rest. And I put something on the table here to put more fire on more oil on the fire here. Let us think for a minute about how we deal with unanticipated change in computer systems today. So if something happens that was not expected, what do we do today? What we do today is we go to the table, we design, or we create something new and we deploy that so that we can deal with that problem that emerged. So what we do today for dealing with things that we have not anticipated is basically we evolve a system. And actually, I'm advocating the question in the sense from that point of view. I agree with many of you. Also, Thomas, you said it's technical. I agree. I agree with all the challenges that have been raised here. But I would also say, why would it not be interesting to see, in fact, evolution is getting automated more and more. Can we not get this automation into our loop of self-adaptation and let then the machine evolve the system with humans involved there where they are needed? I'm putting this just on the table for more fire, as I said. I would like now to give the word to Jeff Kramer. I think he was first with his hand.
Well,
hi.
I didn't.
Yeah, finding the unmute button is my only problem at the moment, let alone trying to actually answer all of those questions. I don't know if people have been following the chat line, which I have to say it's been more active even than the speakers. I'll try and present my position. I mean, clearly a lot has been presented, and clearly we can't do the impossible. I mean, adapt to completely unexpected things, I think, of course, is going to be impossible because there are always uncertainties. We cannot model everything in the world. We cannot model the real world with all its detailed stuff. So inevitably, everything will have uncertainty within it and will present us with unknowns or unexpected events, or however Bashar would like to define that. However, what I think we have to do is, we are technical people and we need to concentrate and actually focus on something which we can make progress with. And the thing we can make progress with, I believe, is the building of good models. And the point in the end, which I think goes to Danny's point, is moving essentially what we used to do. We used to take our systems offline. We used to do system maintenance, went through a requirements engineering process to re-specify what features and new things to try to take account of whatever changes we wanted, consult our stakeholders and everyone else, make the modifications and put it back. We're moving all of that to happen at runtime. This is the whole point, is to make that faster and to not have to take systems offline in order to do it. And the reason that we can actually have some possibility of doing this is essentially by building online models. And these online models, what I think Gregor called the twin, essentially allows us to reason about what the system is doing at runtime. So in terms of, for instance, what I think Ivana was talking about, trying to detect something which has happened and we don't have the right sensor there, what we have is an indirect effect which tells us that something is doing, one of our assumptions has been broken. And we therefore have to try to react for it, either by putting in more sensors into the system and trying to do this at runtime. It may not be a fast thing to do, but this demands reconfiguration, it demands thought, it demands models at runtime, it demands reasoning, it demands then modification of the models as we learn more. And all of this process can actually be done and is a technical question. And that is where I think we actually should focus our work. I mean, I think what the other Jeff Kay was talking about in terms of goals and setting these goals, we learn, the system learns while it's running. And this is an opportunity to essentially, as it says, present users so that they can recognize what they want and also recognize what they don't want. So I think we have all of this possibility there. Whether it is the ultimate challenge or not, I couldn't answer, but it's certainly the major challenge. And supporting that will certainly see me through my lifetime. Anyway, as I think somebody said, there's certainly enough for all of the researchers out there, all the young researchers, to see them through their lifetime as well. Anyway, that's my position. It all sits in runtime models.
Thank you, Jeff. I first would like to repeat, if you like to talk here, it is impossible for me to really scroll to this chat and understand, so please raise your hand. I will now give the word to Poyan, who is the next in line. Unless Bashar, you were earlier, but you will have to wait a second.
Bashar was earlier, so Bashar, go ahead, please.
Okay, Bashar, you got the word.
Oh, so thank you, Poyan. I think your hand was before me. So hello, everyone. Sorry, I was the equivalent of whispering in the back row through the chat. So my apologies for that. I think I caused some of the disruption there. I'm used to sitting in the audience and yeah, loving things from the back. So I want to just start by slightly disagreeing with Jeff, which is a risk, which is I don't think we're just technical people. I think increasingly we need to be socio-technical. And adaptive systems, the real sources of uncertainty are in the world in which these systems sit. So unless we understand the world in which these systems are going to operate, we have no chance of understanding the kinds of parts of the world that we need to model, even though I do acknowledge that modeling is very important. So just to get that out of the way, but maybe to add to the agenda that I think we should be thinking about, two words that haven't been used in this discussion so far that I think are important, and they come from a requirements perspective a little bit. The first is emergence. So I think if we think of systems as needing to cope with an emergent world, changing properties of the world, and that the systems themselves also need to somehow evolve to be able to cope with these emergent properties of the world, then I think we might have some handle over some of these terms that we've been talking about. So I would urge people to study quite a lot of the literature on emergence, which I think is quite important here, because I think it might help us build better models of the world and perhaps think about how we move systems from the state in which they are somehow delivered to the state in which we want them to adapt to. The second notion, which I'm surprised I didn't hear about, is the notion of conflict. So we somehow assume that knowledge is known and then the system can reason and then decide what to do. We assume that sensors are giving the consistent information about the environment. We assume that customers have or users have agreement in terms of what they want the system to achieve. And I think these are really hugely challenging problems. And I know things like uncertainty are difficult and prediction are difficult, but even more important is to be able to understand these emerging conflicts and these emerging inconsistencies and these emerging problems in the world that we need to deal with. And I think being able to model conflict and being able to get the system to recognize that there are alternative options from other systems it might be interacting with is really quite important, because there is no such thing as one single adaptive systems. There are probably going to be several in the world, and that they have to interact with each other as well as with their users. So I put those two issues as at least equally as important as unanticipated changes on our agenda as well.
Okay, thank you. Gregor, do you have anything directly to Bashar, or do you have another topic?
So if Bashar doesn't sleep again, I can wait.
Okay, good. Then Boyan, it's your turn. Maybe first, let me ask one other clarification question, Bashar, to you. When you say emergence, are you talking about something as novelty discovery, or is it something else you really want to say here?
I think I'm referring to a whole set of things that can happen. So sometimes, I mean, in systems engineering, emergence is a property of a complex system,
right.
in which it starts behaving in a way that was unexpected. But you can also talk about emergence of ideas and emergence of properties of the world, in which our understanding of the world also changes, and therefore our requirements and therefore demands on the system change. So
Okay.
it's a whole range of issues, I think, that I covered by that single term.
Yeah. Okay. Good. Thank you, Boyan. Then it's your turn now.
Thanks. Hi, everybody. Thanks for the discussion. I learned a lot. So about this uncertainty, I would like to add two things. I like the thing that Gregor mentioned, and I agree that uncertainty actually comes from our ignorance, not knowing what's happening in the world, which is true. But I don't think that the learning in the way how mainstream ML works is the solution. Because there are multiple issues with that. I have some thoughts that might be applicable here. One is that, first of all, it is important to, when we don't know the environment, the uncertainty in the environment, don't assume that it is a dumb environment. We should assume that there is actually an adversarial environment. So in particular, to add a little bit context here, we have a fantastic project with NASA. Actually, Bradley, Javier, Davids are also involved in this. So this is about deep space when we send robots to Europa Moon, for example. And actually scientists don't know anything, don't know much about this environment in terms of radiations and so on. The way how we want to approach it is to assume an adversary, which is a kind of crazy adversary that produce this kind of type of uncertainty. And then at the same time, we could find a way or mechanism to cope with this. So this basically assuming that the world is adversarial and could learn from even our interaction with the world and basically learn much more about the system itself is important. The second thing that these days I'm looking into this causal mechanism. So in order to learn, so in contrast with the statistical way of learning, this mainstream ML world, I don't think that this is the way that could help system to cope with uncertainty. But on the other hand, by identifying these causal mechanisms, that we could repurpose the skills that we have learned, the robots or the systems, autonomous system have learned, and repurpose it to quickly in order to learn newer skills, in order to cope with this new environment and uncertainty, or repurpose the same skill in this, uncertain world is a way that I strongly believe this is a way to go and approach it. So these two things that I wanted to add. Thanks.
Thank you, Boyan. Thank you. Gregor, now it's your turn.
Yeah, thank you. So I was expecting that today we speak much more about the involvement of humans in those systems we are looking at, because quite often it was said that uncertainty comes into the play when we have humans in the loop. And so a little bit surprised, and this was not expected for me that we don't speak about humans. And if you look into my slides, so I say that the managed system we have are the cyber-physical social systems where humans are part of. And also, I think, okay, there was a comment in the chat, the MAPE-K is outdated. But anyway, if we have this control loop and we have this feedback loop and so on, or MAPE-K, then in the knowledge part of this MAPE-K should not only have information about the technical system, but about the whole system. And so if we would like to control, to monitor, to steer cyber, physical, social systems, then we need much more knowledge about what we have to monitor and to store about humans in these systems. And this is really an open issue for me. And I'm a little surprised today that we don't mention the humans. And my answer to this is that I'm not really surprised about this, because I'm the last 5 years worked a lot together with people from psychology and sociology, and they speak a lot about the digital twin of humans. But if I only speak, and I'm a little bit provocative, if I only speak to you as computer scientists, I'm not surprised that you don't speak about humans. So let's think about, there was also the idea of having a Dachstuhl seminar, let's think about how to involve people who know more about humans than we know as computer scientists into this debate. Thank you.
Thank you, Gregor. Very nice.
I totally agree with Gregor's point, and this is partly the point of our position paper.
I would like to raise one issue here that is really related. So then I'll give the word to the other people that are waiting. Gregor, you and also actually Thomas was talking about, and pretty actively, changing the context. Now, I can imagine that you, for instance, said, okay, I reason about humans, and then I want to influence humans to do things differently. But I'm maybe old-fashioned, but I still think that the context is something that is in principle out of your control, that you might through affect, but you cannot.
No, I don't agree, Danny. If you look at what's happening today with Facebook and those networks, they influence you by Amazon. They give you the information on the website you like, because they know what you're looking for. So they influence the context, they influence the reaction of the system. They even influence maybe the climate to make it, or they influence the music in the store where you are buying. All this, so they influence the context to make you feel more comfortable in your situation.
Okay, but I think we are in line, because you use the same word as I use, saying you can influence it, but you can actually not change it, but you can influence it. And that might, if you have a powerful mechanism, that leads to change, and probably with a very high guarantee, but
it depends what you mean by change. So if you change the light in the room, is it a change or an influence?
Yeah, that's a change, because you have control. You have built it. If I push on that button, it will change. But there are things that are in the environment you cannot change. You can just influence it, and we do that all the time with every system we build. And often we have, of course, very good knowledge of the environment, and then when we try to change something, it will change. If we push the elevator, it will go up, but we have built it to do that. Anyway, it's a philosophical discussion, but I just noticed this issue. Maybe it will bring us a bit too far, but I agree with you that things are changing in that sense as well. Betty, it's now your turn, please.
Thank you, Danny. I just wanted to reiterate a comment that I made in the chat, and I've actually refined it even more given the follow-up discussion. And first of all, I think that there is probably not an ultimate challenge. I feel like we have lots of challenges, and I think that given the modifications to the current statement of the challenge probably reflects that. But I feel like one important guiding challenge would be to develop techniques and technologies to ensure acceptable behavior as defined by changing requirements, right? So it is centered around requirements, but the idea is that these requirements may in fact change. And I think a lot of these challenges are centered around the fact that we have to deal with uncertainty, and there's lots of dimensions of uncertainty, whether it's environment, human nature, the changing needs, etc. But I feel like a lot of the relevant areas were discussed by the various panelists, including digital twins, humans in the loop, also socio-technical systems, predictive technologies, including machine learning, evolutionary computing, probabilistic analysis, gaming technologies. As Jeff mentioned, models at runtime monitoring and assurance, multi-objective optimization, because we may in fact have to deal with conflicts while we're trying to ensure acceptable behavior. And I think one thing in terms of the pragmatics of all this technology is, how do we deal with certifiable assurance. We do a lot of work with the government as well as industry, and we might have these nice fancy capabilities, but unless we have a means to demonstrate that they are in fact delivering the intended or acceptable behavior, there's a lot of skepticism. So I think that we need to bridge this gap between what we're trying to do in research with what people are willing to accept in industry. But I go back to sort of my roots, and that is about assurance. How do we ensure acceptable behavior in the face of changing requirements and also uncertainty?
Good. Thank you. Good point. Janina, now it's your turn.
Hello, everyone. It's a very nice discussion, and I really thank for everyone for the not only the presentations but also the discussions that I've seen here in the chat. There is one thing here that I haven't seen much discussion about it, but maybe this is between the lines. Difference between things what we mentioned about precision and accuracy. So I think that maybe we can move towards a precise knowledge, but not accurate knowledge. But then in the end, that's what science is all about, right? So we know that we don't know everything, but we learn the things as we evolve. So this is a principle that we are all following to live better, right? So even like medicines and all the advances that have in science for our better lifestyle. So I agree with Ingrid when she says that maybe this is something that will go on and on. I mean, we don't have like I don't think that we have an answer here saying, okay, this is the silver bullet for the problem. But if we can represent the knowledge about it, so I do agree that knowledge is a key issue here. But then when it comes into the precision and accuracy, then we may have different perspectives on the same problem, or even like we may agree everyone on the wrong solution of the problem. So I think like as I have discussed here, solutions that have been raised in the RE community, requirements engineering community, maybe we can raise our eyes here again and see that maybe there are some solutions here that could we can reconsider here in the works or in contribution. So this is one of the things that the other things that the second thing that I would like to raise. And also what Gregor mentioned, human is part of it. So otherwise we say, we may run the risk of saying, yes, the machines are more important, they can learn and they can do everything as they want, but they're here to serve the humans. And I think the self-adaptation is to serve humans and not to serve the machines, right? That's my point.
Thank you, Janina. Bojan, I will now skip your turn. I will first give the word to Ingrid. I'm sorry, but we need to keep the balance here a bit.
Okay, so first of all, thank you very much, Danny, for coming up with the idea of the debate. It's amazing to see everybody participating and discussing. So first, I have to say something I wrote in the chat, that I feel a bit of agony about reading The Ultimate Challenge, because I think for the ultimate is something very strong. Like we might still not know the ultimate challenge, and I believe there is no ultimate challenge for anything. But for sure, what we are discussing here, it's a challenge. Then the second point is that sometimes I feel we are not talking about software. Like I'm a software engineer, and then whenever I hear the discussions, I try to think in terms of lines of code I would write, and then I get lost. So the point is, software does not do what we want the software to do, but what we tell the software, what we tell them to do, what we write. And there is two ways of doing that. One is to do things in an explicit way. So for instance, with a rule, if the temperature is higher than this, then the software does that. Or we can do that in an implicit way, that for instance, like by learning it, we achieve certain behaviors so that the software is doing something that we tell the software to do, but in an implicit way. The point here is in the end, the software will be still doing what we wrote in our lines of code. But the point is that our requirements are expressed in a more high level way. So this is something, for instance, that Jeff mentioned in his presentation. And also I remember like in the beginning of autonomic computing, there was these layers where ultimately we are going to have an organization that is going to just to give high level directions to the system, and the system will self-adapt to achieve this high level goals. So the point here for me is to understand first how we are going to express these high level goals, and then we come up with the techniques that like what to implement in the software so that the software can be driven by that. So for instance, I'm going simply to specify invariants in my system, and then I'm going to write some code so that the software has an adaptable way to comply with these invariants. So, and I get very confused when people start talking about machine learning and techniques. For me, this is the how, and we are talking more here about the what the software should do. So it's all about requirements for me, and what we are talking here, it's about writing requirements in a very high level and abstract way, and the software is more made in a more sophisticated way so that it can have more flexible ways to achieve these high level goals. So that was what I had to share.
Thank you, Ingrid. I think it resonates well with the few positions we have here. I think in the first place with what Jeff Keppert was saying in his talk as well today as before, but it resonates well. I think this is something that emerges here, if you want, that it becomes really a crucial aspect. Owen, I give you now you the word.
Oh, thanks, Danny. So I actually really appreciated the community's debate so far. As I said before, I haven't been part of this community for a while. In the self-driving world, I currently have the role of what we call a software safety engineer. So that's a software engineer who has to think about the safety of the system. How are we going to write the software to make sure that the car is sufficiently safe for operation on the public road? And in that context, I've actually never thought about scenes or self-adaptive system. I've just not thought about applying the techniques I've heard about in the past or worked on in the past. And I was trying to figure out why. Why is that the case? And I think part of it comes to what Betty was talking about, assurance of the system. That's actually one of my key roles right now, right? How do we assure that the system, the car we engineer is going to do its thing? And honestly, I don't know that I can apply the techniques that I've heard about or learned about the system and know that it's going to do the right thing. And that's something that I kind of need to think about. And I kind of wanted to pose that to the community to think about too, right? My position was somewhat of a nuanced one. I would actually think that Jeff Keppert's position makes a lot more sense. What I was really trying to say through my position, right, was the unknowns are hard, and we can't build a system and deploy it if we can't claim that we've really understood what we're trying to deploy, right? So I have to make unknown known to a large degree for us to be able to say, okay, tell the world, yeah, we're ready, right? So that's a huge challenge for us in the company. And what can we look to the community for help on? To, I'm looking for not just the what, but also the how to help us solve our challenge. So I'll close with that. Thanks.
Thank you, Owen. Nicolas, you are the next in line.
Yeah, I wanted to comment on what Ingrid was saying, because I think she's totally right. And that we need to work on how do we actually attain all these goals. Because, yeah, we're talking about, we need to figure out how to get these unknowns, but that needs to translate to code. And that is definitely not going to happen magically. Someone needs to program this, and that someone needs to be a real developer. Like the code is not going to program itself. That is just something that is not going to happen. But we do have techniques to be able to plug in different parts of code to be able to get this information that we're receiving about these new situations that we don't know about, to be able to put it in terms that the system can start trying to use it to understand what is happening there. How is this new information changing? What is the effect on the system? And we can actually plug all those things in the code. We need to make the code a lot more open to this because right now we generally program our systems in a very closed setting, and we don't allow like new behavior to come in and change things, because obviously that is problematic. That is also a problem that we need to address. But I think that the discussion is going towards how do we actually represent things that the system didn't take into account, that maybe we as developers didn't even know about, and how are we able to integrate those in a safe way? I think that if we're talking about adapting to our certain situations, that means changing the behavior of the system, and that will bring like security and safety problems for any kind of system.
Thank you, Nicolas. Okay, the last intervention now for the discussion here. Elias, you can do that.
Oh, I didn't want to be the last. My view, very quickly, thanks a lot for all the different views. I agree with almost all the presenters, because I think they kind of set the light on different aspects of the question. I still don't know what is an unanticipated change, one thing. I agree more than with Martina than the rest on her point about we need to, I think, be able to focus on the uncertainty and the type and amount of uncertainty. When I say uncertainty, it's mostly the operational uncertainty, right? I think this is the key. I believe this is the key. I know that there is a lot of work already done by, for example, Dani on the matter. I think this is very, very important to kind of all of us try to get a good grasp of what we mean by operational assumptions and what we mean by operational uncertainty, and how we specify it and how we model it and how we use it in our adaptive systems.
Okay, thank you, Elias. In fact, it's good to hear. We have a Shonan meeting planned on exactly on the topic of uncertainty, involving people from this community here and other communities. So that will be an interesting occasion to further go into this. So the rest of this final part here now is, first we will do another round of voting and see what the opinions are after all these presentations and discussions. So Elias, can you show the...
Yes, let me share. And this time I will, oh, sorry. You can see my screen, I guess. And I will also copy the link so that you don't have to do much. You just have to, where is the chat? Follow the link or go to menti.com and give us your opinion for the second time on the same question. Let me see, voting is open and now results are hidden. So, and you have, again, 2 minutes.
So we will be very curious to see what happens now. Okay, we're almost there. Okay, thank you all. So Thomas will now show another last, not the last but one slide where you can now express whether you have changed your opinion, yes or no.
Okay, I will leave this open.
I thought you couldn't reveal the results until the polls closed.
I control this, and for this particular question, there's no bias. It's either you change your opinion or not. However, even this question is not framed maybe 100% accurately. So maybe I can leave it open for some people. So the point is whether if you shift from tend to agree to agree, if this is a change, what do you think, Danny?
I think if you changed your mind in any way, it is a change. Yeah.
It is a change. Okay.
Yeah.
So for the ones that were wondering about it and did not really vote, because it's very important to clarify this. Okay.
Yeah.
And now I can think we will show the results of the previous and the comparison.
Yeah.
Okay, so there's still a couple of votes coming in. So it's nice.
Yeah, a lot of people change their mind. It's surprising.
There's also a question about anticipated or unanticipated change.
Okay, good. Elias, then I suggest you show now the results of the two voting. So.
Okay, so keep sharing and do the trick. Okay, let me see how to do that. This is it. So basically, I can see the number is 59. And here we are in the live editing.
Yeah, this is a lot of impact, these discussions, guys. We moved from being very optimistic to be a little bit more pessimistic, if I see it like that. No?
We can change the context, Danny. Huh?
Kind of what happens during a paper discussion for PC. The more you discuss, the more negative it gets.
Yeah. It's interesting to see. Yeah. Okay, thank you. Then we will now conclude. And to conclude, we have talked here a lot about challenges, and we all have opinions about what are the big challenges. So Elias, can you show now the next and last request for input? What we will do is now we will look at what are the main challenges according to you, and you will get the opportunity to provide 5 entries. Take care, every entry has maximum 25 characters, so you might just use keywords when you phrase your challenge. You can do 1, you can do 5, whatever you like. You have up to 5.
Danny, do you want me to show the results or hide them until everybody votes?
I suggest that you hide them, and then at the end we will show it, you know, in the format that we said.
Okay.
Go to the same link.
It's still the same link, yes. It's still the same link. Just when I switch slides, then you should now see the new question. I see this takes a little bit more time. think you can also look at the chat for inspiration.
We unmute it. We give it 1 more minute and then we will conclude here.
We have 18 answers. Now you can see. The link, let me paste it again. It's just very high up. It's here. Just to stress you a bit.
Yeah. So it's important that you enter your IDs now because it will define the agenda for our community in the next years.
So we have 1 minute to think of it and 5 years to actually do it.
Exactly. Yeah. Okay, thank you very much. Elias, then I suggest that you now can show the results.
Okay, let's see.
So the words are not so surprising. Maybe one thing that has surprised me is that requirements or goals, if you like, is so central here.
Yeah, Bashar edited 5 times.
Yeah, maybe 5 times the same word. Okay, I think it was a very nice debate. I'm happy with what we did here. I will tell you now that we will process all the information we got and we will produce a report of it so that we can document it for the future. What happened here today in our debate. So this concludes the debate, and I invite you now to join us at what is it, Gather Town, Elias, right? You're muted, Elias.
Yes, I'll stop the recording.